This is pretty funny. Carla's got heating pads on her boots. It's pretty cold outside. All right, another week. Time for another question show. Before we get into this week's question show, I've got a couple of points of order. One is I've been trying out this new YouTube community tab. It's pretty cool. I've been posting a bunch of ideas for episodes. So actually the next several episodes that are coming up have been chosen by the viewers, and they voted on which ones they wanted to see. So if you notice that community tab coming up, I'll try to put up polls that you can actually vote on episodes that you want me to cover. Second, I've got a bunch of questions. I asked my patrons to come up with a bunch of questions that I could tackle, and so I've got a few at the beginning and then on to the rest of the questions. As always, wherever you are on my channel, just type in your question. I will gather them all up and answer them here. All right, let's get started. JM Autobot. Since dark matter has gravity and there's a huge amount of it everywhere, could we use gravitational lensing with dark matter to explore the universe? Good news, astronomers already do this. There are some amazing gravitational lens discoveries where astronomers are detecting these galaxies that are really far away, and they're using galaxy clusters surrounded by enormous amounts of dark matter as this natural lens. So this is the part that I think is so great about dark matter, is that astronomers still haven't figured out what dark matter is, but they use it as a telescope, which is just great, right? You don't know what it does, what form it actually takes, but you're able to use it as a telescope and use it to study the universe around us, which is just great. So as soon as we know what it is, then we'll know what we were able to use as a telescope. It's awesome. Rockomax. Planet hunters seem to find quite a lot of super-Earths. If super-Earths are kind of the norm in the galaxy, it may be harder for any intelligent species living on a much more massive planet to set up a space program. What are your thoughts on this? We don't know what is the ratio of super-Earths to gas giants, to rocky planets, to Earth-sized worlds, to Mercury-sized worlds. The problem is that today our technology is really only good enough to find either the large planets, the Jupiter-sized objects orbiting sun-like stars, or some of the smaller planets that are orbiting around red dwarf stars. But we really just don't have a comprehensive survey of everything that's out there. We expected, 20 years ago, that star systems out there would look kind of like our own star system. But it really looks like now there are all kinds of things. And the other thing that's really interesting is that it now seems that the size of the planets within the system tend to be very similar size to each other. And so the TRAPPIST-1 system with 7 Earth-sized worlds orbiting in the habitable zone seems to be the more common outcome right now. But there's no real evidence that, say, super-Earths are more common than regular Earths. Now, if you did form on a super-Earth, you would have a much harder time having a space program. The size of the planet and the density of the planet do matter. And so a lot of these, what we call super Earths, could be mini Neptunes. They could be small ice giants, things like that. But if they are rocky worlds like Earth, they're going to have, perhaps 1.5 times the gravity. And we're at the very limits of what kinds of spacecraft we can launch using chemical rockets in 1 Earth gravity. To push up to 1.5 Earth gravity, that would be really tough to get any significant cargo off into space. Clem Unger. What happens if Curiosity Mark II or another probe finds life on Mars? That can have a significant bearing on human exploration of the red planet. NASA has a planetary protection protocol in place with their robotic missions. Surely the protection of life on Mars cannot be guaranteed with rather unsterile humans wandering around. There is a collision coming between the scientists who want to keep Mars as pristine as possible to be able to explore it, and the folks like, say, Elon Musk, who want to colonize it. And absolutely, if we put humans on the surface of Mars and they're near these reservoirs of water and they're getting regular shipments from Earth, no one's going to be able to take the time to properly decontaminate and clean everything that's going to Mars. So if contamination is possible, then it's going to happen. And there's nothing that the scientists are really going to be able to do about it. So my guess is that there is a fight coming. Right now, everyone has just said it's not worth talking about because nobody's serious about sending a private mission to Mars. But now, Elon Musk launching the Falcon Heavy, they're getting very serious about sending humans to Mars, and this question is going to come up again and again, and I think we're going to be seeing a lot of fights. I don't know whether anyone can stop them, regulate it, but I think that we're going to see a much bigger pushback from the scientific community about this, just sending humans to the red planet, and hopefully they'll reach some kind of compromise about how you clean the spacecraft, how you clean the people, how you clean their supplies and things like that, and where you're allowed to land to try and minimize any kind of possible contamination on Mars. Stephen Riley. What would we need to do logistically to clear all the debris from Earth's orbit? If we develop the technology to send a crew and specially designed ship to collect up all the material, could they salvage these dead satellites and debris? The problem is that the spacecraft are orbiting, in many cases, on different orbits. And so each spacecraft that you would want to try and collect, each bit of space garbage, you would need to match its orbit, rendezvous with it, grab it, put it into some kind of receptacle, and then eventually deorbit it. So for a lot of spacecraft, they're kind of going in fairly similar orbits, but if their orbit is different enough, then you're going to need a tremendous amount of energy to switch from one orbit to a different orbit. And so there are plans in the works to have these spacecraft that would fly up, dock onto a satellite, and then do a burn that would bring it back down into the atmosphere. There's other ideas of spacecraft that might go up to, say, geosynchronous orbit and move around within the geosynchronous orbit and try and gather up spacecraft. Some really neat ideas, like even like potentially using electromagnetic field to try and attract objects to it if they're close enough. So they're having a lot of ideas, but the reality is that literally every chunk of garbage that's up there that isn't going to just deorbit naturally, you're going to have to come up with a plan. You're going to have to send a spacecraft. It's going to have to match the orbit. It's going to have to do its job. And then that's one piece. And there are thousands and thousands of pieces on different orbits up there in space. This is an enormous problem, and it's going to require spacecraft and logistics that is really, people just are underestimating how much work it's going to be. And of course, we've talked about this idea of the Kessler syndrome, this idea that the spacecraft will start to smash into each other and turn into smaller and smaller pieces, and the problem gets worse. And then to even fly through this shield of debris is going to be a really dangerous process. So it's one of these things that we will need to sort out. It's expensive, complicated, requires engineering, and yet the longer we let it wait, the worse it could potentially become. Trip Zero. Fraser, we need to talk about the case for Mercury colonization over Mars. Elon is making a big mistake. Well, if you've watched enough of my videos, you know I'm not a big fan of Mars colonization. I'm not a huge fan of moon colonization, and I'm definitely not a big fan of Mercury colonization. I mean, I get it, right? There are permanently shadowed craters on the surface of Mercury. Mercury is really close to the sun. It receives an enormous amount of energy from the sun, so you wouldn't have any problem with power. You could dig down below the surface of Mercury and live in tunnels to try and minimize the amount of radiation that you're getting. But just all of these things, they just sound, I don't know, like I want to live on Earth. Earth is great. Earth is the best. It's got trees and clouds and animals and things. But I personally think that living in space is the future of humanity. We want to figure out how to live in space itself, in orbiting, rotating spacecraft that produce artificial gravity inside of them, somewhere relatively nearby the Earth, and eventually to other, Lagrange orbits and Trojan orbits and things like that. Is it a better thing to go to Mercury? You get more power. But you have to live underground. Is it better to live on Mars? You get less power. You've got a tiny bit of atmosphere. Maybe you can terraform it. You got to live underground. They both have fairly low gravity compared to Earth. Like, there is just an enormous amount of problems that we're going to be facing in either one of these. And so I think probably the more likely solution is, if you're going to colonize one, also colonize Mercury. Like, figure out both. and maybe colonizing the cloud tops of Venus. But I don't think Musk is making a big mistake. It's really hard to get down to Mercury within the solar system. So, but I'm sure this is an argument that everyone's going to have. I have my opinions. You guys have your opinions. I'd love to hear sort of your opinions in the comments below. Yash Chuhan. Could it be possible that life and creatures made entirely out of dark matter, just like our building block is carbon? I don't know. We don't even know what dark matter is. Like, is it a particle? Is it that gravity doesn't work as we expected over vast distances? Although that has been kind of ruled out. It's probably a particle, but what kind of particle? It doesn't look like the particle comes together in any way. It doesn't seem to collide with itself, and you would expect that a creature made of dark matter would need to have these particles clump together, and dark matter doesn't seem to want to do that. So we don't even know what dark matter is. Once we figure out what dark matter is, then maybe we can start to make some speculation about how it could form life and things like that. So it's one of those things that we're so far, we're just at the very, very beginning of understanding this phenomenon. We literally just know that it's there. That is as much as we know about dark matter right now. It's there, has mass, affects with gravity, doesn't seem to interact with itself, doesn't seem to put out any radiation. That's all we got. Nihil. Hey Fraser, if the moon is getting farther from Earth because its orbital period is longer than the Earth's rotation, then is Earth getting farther from the sun because its orbital period is longer than the sun's rotation? I switched to gloves. Hands are getting cold. Yes. In theory, if there was just the sun and the Earth, and the sun lasted forever, then the Earth would be drifting outward and would tidally lock to the sun. But the thing is that we don't exist in this sort of perfect environment. We exist with all of the other planets, and the Earth has the moon going around it, and the sun has a lifespan of billions of years. And so within that time, the Earth is not going to be drifting away from the sun until the sun's mass starts to change as it turns into a red giant and blows off its outer layers into space. That's when we're going to see the Earth's orbit significantly change from what it is today. But we do see other planets orbiting other stars, and we've got to assume, things like hot Jupiters or the planets in the TRAPPIST system, we've got to assume that they're tidally locked to their star. So they drifted to this point that they were locked down and only showed one face to the star, and then that was that. And that's what's happening in the Earth-Moon system, is that the Earth and the Moon want to eventually get tidally locked to each other, so they only show one face to each other, and then the rotation rates won't change and the distance won't change anymore. They're done, they're fixed, it's over. But the solar system is just too much of a chaotic place for this to happen. Helios Legion. Could this be a solution to the Fermi Paradox? Most Earth-like planets could be too short-lived for intelligent life to develop, while species evolved on ocean worlds are unlikely to even discover fire or chemistry before going extinct. At least another filter to technological civilizations. We don't know what it would be like to be under the ice. What kinds of life forms would evolve on those worlds? And absolutely, we can sort of think of fire as one of these big technological solutions. Like, it was really just about getting out of the ocean, up onto land, learning to use these technologies that helped us grow towards becoming an advanced civilization. And we don't know what kinds of limits there could be for some kind of species that evolved under the ice. As I mentioned in that episode, the amount of, the complexity of the life forms is likely to be less in the density, because they just don't get as much energy as we do living out on the surface and bathing in the sunlight. But that said, there's 1,000 times potentially more worlds like that out there than the habitable zone worlds like Earth. And so, it's like, I can't imagine a way that a European space whale could develop technology and begin a space program, but that's probably just a failure of my imagination, right? So I think the bigger question is still, we go back to this question of the Fermi Paradox, which is like, for sure, if it happens on every single possible ice world, there's no way that they can ever achieve spaceflight and communicate to the outside world, then that is an explanation for that portion of the Fermi Paradox on why that is the great filter for anyone growing up on an ocean world. But we're here on a rocky world in the habitable zone up on the surface, and we're making our way towards being able to do space flight and communicate out into the universe. And so the question is, why don't we see those civilizations? So I feel like it doesn't really answer the Fermi Paradox. It sort of answers one chunk of it, but it still doesn't solve the bigger question. We should see the ones on the rocky worlds, and we don't. Alexander Hoffman. Are there any potentially hazardous materials that we should be concerned about when satellites re-enter the Earth's atmosphere? There's probably like various trace elements on satellites, but the one that we're most concerned about is this thing called hydrazine. And this is used as rocket fuel, a lot of the, as propellant for a lot of spacecraft. You'll see them sort of blasting out propellant when they're out in space. If you watch The Martian, there's a whole episode, a whole chunk where he turns this toxic propellant into water so that he can drink and grow crops. And this stuff is very toxic to humans. And so you can imagine when spacecraft fall down back to Earth, they could leak hydrazine. One of the other issues is, some of these spacecraft, especially some of the classified ones, can have nuclear materials on board, like uranium. Some of the spacecraft that go up into space, like the Cassini orbiter and Galileo and things like that, have a nuclear RTG, the radioisotopic thermoelectric generators, and they're made with plutonium. Now, there's still controversy, and none have ever been lost, but there's still kind of a controversy on whether, if one of these spacecraft gets destroyed on launch or in orbit, will the material stay fairly tightly together and actually not escape and explode? And so I think there was a lot of fear-mongering for previous launches. But there are just these toxic chemicals on board that you just don't want to go anywhere near. So once again, if you see a spacecraft land, stay away, call the authorities, let someone come and clean it up properly. Rob Stewart. You mentioned pollution to space, but what effects are these rocket launches and deorbits having on our atmosphere and oceans? So the effect that the spacecraft is having on our environment really kind of depends on the propellant. So I'll give you a good example, right? When the Saturn V launched, its rocket was liquid oxygen and liquid hydrogen put together, and the exhaust from that is water vapor. So that is not necessarily a toxic chemical. And so a lot of these spacecraft that use this hydrogen oxygen fuel, you can imagine, like, what is the contrails? Water vapor in the atmosphere can be a greenhouse gas, so that's a problem. When you've got things like the solid rocket boosters, they use like aluminum oxide, and that stuff burns and produces particles and particulates up into the atmosphere. There could be issues with that. One of the but right now the number of rocket launches that happen is fairly minimal. We're in the dozens of launches in each country over the course of a year, as opposed to the hundreds of thousands of airline flights that are happening all the time over the course of a year. So I think that right now it's just a matter of, it's a sense of scale. But you can imagine as the rocket launches scale up, then these issues are going to be bigger and bigger. One of the cool ideas, for example, with the BFR from SpaceX is that it's going to be powered with methane, and it's going to have a reactor. It's going to be able to produce this methane right out of the Earth's atmosphere. So in theory, it's going to be carbon neutral, right? It's going to use electricity to generate methane from atmospheric gases and water, and then it'll burn up that methane and return that carbon dioxide back to the atmosphere, but it'll be carbon neutral. So I think that over time, the rocket companies are going to be expected to come up with a solution, just like transportation companies, just like car companies, to deal with the carbon emissions that they're creating. And it kind of sounds like SpaceX is pretty ahead of the curve on this when it comes to building a rocket system that is essentially carbon neutral. Dragos Murga. Do you think it's theoretically possible to shatter a rocky planet by somehow creating constructive interference in it? Like you could shatter a glass of wine with sound, for example. How would you produce this at a planetary scale? I think there's the idea that Tesla had said that he had come up with some kind of thing that he could shake, and it would shake apart buildings and maybe even shake apart the whole planet. To destroy a planet, and we covered this in an episode where we talked about the Death Star, you need to essentially you need to use more energy than the gravitational binding energy of the entire planet. In other words, you've got all of the energy that is gravitationally holding together, all of the matter in the planet. And it's an enormous number, right? Huge. And so whether you use some kind of constructive interference, or whether you just hit it with explosives, or whether you zap it with your super laser, you need to put in more energy than the gravitational binding energy of the entire planet. So I don't know what the exact mechanism would be, but if you're not bringing that much energy to the table, then you're not going to be able to destroy a planet. Fort Nikita Bullion. Do you think man will ever walk on Triton? So Triton is the largest moon of Neptune, and it's one of the most interesting places in the entire solar system, and I would love for us to be able to send a spacecraft back there and to be able to study it. Should we have humans walk on Triton? I don't know. It sounds like it's going to be one of those things like what is the scientific use of having people walk, climb up to the top of Mount Everest? It's a challenge. And so I can imagine in the far, far future, maybe hundreds of years from now, people are going to try to land human explorers on Triton for the experience of it, I think, just to show that we could do it, because you're looking at a multiple decades mission to get out to Neptune, to land on Triton, to walk around, and to come back. But I love this idea of this future where adventurers and thrill seekers are trying to walk on other worlds out there across the solar system just to try and do it, which would be kind of amazing. All right, that's it. That's the end of this question show. Thanks everyone who put in your questions. As always, if a question pops into your brain, wherever you are on my channel, just go type in your question, I'll gather them up and answer them here. We'll see you next week.